the learning methodology. And similar to that, so what I did is, in this 4 concept, we have piled up around almost 40 experiments, okay, and we'll see one by one actually. And I don't think we have the time the whole day. Today is the, 1-day workshop it is. So what I'll be doing is, some of the experiments I'll be giving the hands-on to you so that you can do it and learn it. And some of the experiments you don't need to do it actually. You'll be already well known about that concept, but you can just grasp the things so that it'll showcase it to the kids actually. Okay, so here my mode of explanation will be here more into the concept. I'll be providing you lots of experiments, but and little bit information how you can engage these experiments with the kids actually. Post to that, the way of explaining these experiments needs to be like your own idea actually. Post. So that part will be good. So we'll start with the catapult making. So necessary things are that lollipop sticks, like 15, and elastic bands. I have elastic bands with me. You can. You can pass it on actually. So each one can take almost some 30 to 35 elastic bands approximately. Don't need to count, just take and share it up. Oh, okay, sorry. So whenever you give a task, it no start. Explanation them, okay, step 1, do it like this, step 2, do it like this. At the end of nth step, you'll be completing the experiment. Okay. For all the experiments actually. Some kind of photo or some kind of snapshot. So on seeing this snap, you will be knowing you will be using this. You can ask them, okay, on seeing this experiment, what are the components? Ask. Okay. So here, in this experiment, almost some 15 sticks are required, and enough rubber. Yeah. Want any one of you from next one? Okay. Yeah. See. There's a catapult, wherever there is a elastic logic is there. So it will be like a wooden piece, and this will be an elastic strip, and there will be a holder to hold some stones or something actually. So this will be used for hunting purpose or something like that. Will be using it. So this is one application, and generally they give a common name for this also, catapult. And one more thing is an olden days, like when the war is happening, the forts and all will be constructed with the huge walls. They'll use some metallic, sorry, not metallic, stone. Like it doesn't have much power to this sort of catapult mechanism. In that gap, it will be in a bigger in structure, and this in the cork also will be bigger, and they'll keep big stones in the cork actually. So once they trigger this catapult, that big stone will be hitting on that wall, and it will damage the wall easily. So in olden days, the wall is the only protection shield actually. So to damage the wall, this is the popularly used mechanism in olden days actually. So this is a miniature version of it with the same the working concept. Everything is more or less same with both the things, but it's in a miniature version. So here, like when you attack while attacking the fort also, there are 2-3 things are there. Like at what force the stone is heavy, the stone is. Things need to be calculated. Single stone is easily breakable. So if they made it a double stone one, it will be tough to penetrate actually. So the stone size should be bigger. You can build a bigger catapult, or you need to alter the engineering logic to increase the force actually. Okay. You got it now? You understood what is catapult, right? Yeah. So this first thing, like I'll just brief you how to start with this. So I'll go with a step-by-step method for this thing. Okay. So am I audible? You can hear me, right? Right. Yeah. So we'll first do the base actually. The base 4 sticks are there. That we need to make it up. So keep the sticks like this in a 90 degree. The corners should be like this. And the rubbering method, you can put the rubber band in any way, but the simple, the good mechanism is like you need to put like this, make a tilt, and bring it like this. One step, do it like this, and rotate it. So close to the rubber band, it should stay in the right angle. You want me to do it again or? Once more. This is not a fixed procedure, but it keeps it in a right angle shape. So hold it like this, take a rubber band, put it like this, okay, and make a twist, then take it in the slot, then make a rotation, and again put it back in. Or you can use your own method. It's not necessary to follow this thing. You can use your own method. Okay, now? Yeah. This method will keep this thing in a right angle. In a right angle. Got it? Similar way, you need to add 2 more sticks and make a square. So you can adjust the sticks to make it even. One is like coming out, one is slightly or shorter. You can adjust it to make it even. Yeah, that's fine. So again, like you need to take 2 more sticks and make it not like this. So one corner. Yeah, same. Not out of it, just you need to use 2 sticks and make a binding in one corner. So you all have a bottle top there. So you take one close to this. So right now these are the subcomponents you will be having. One square shape and 2 V shape. Okay. And you take one new stick and use the bottle top and stick it like that in one of the corners. One stick and stick the bottle top in one of the corners. You can use Fevicol. You can do the sticking first actually, or else it will take some time to fix it up. So do the sticking and then we'll go with the remaining process. Mostly the completion of these three sub parts, go for the stick. See, as shown in the picture, just in one of the corners you need it. In a fresh stick. Take a fresh stick, and yeah, like that. In one of the corner you need it. Yeah. And then keep it aside for drying. Yeah. Like this. Yeah, paste it and keep it separate. Let it get dry. So now we'll go back to the previous sub-component. Take the square and the V-shape and do the V-shape inside the square like this. And hold it like this and put the rubber band in both the corners. It won't stay vertical like this, but don't worry. Rubber band and put it. But it should get knotted like this in the corner. And do the same with the other component also. So for this thing, choosing the smaller rubber band is better actually. If you are using a bigger rubber band, you need you got a structure like this, right? Now keep on one more stick at the top, like this, like vertically, and the gap of two. Put a rubber band. Now you will get the proper structure. Like this and put a rubber band. Don't worry about the structure. Once you put the top one, you'll get the proper structure. Just put a post it up, you can adjust it. You can adjust and make it to look like this. If somewhere you are not getting enough strength, we can use one more rubber band. Okay. Yeah, that's fine. Now, we'll take one more step. And this part, like, it will be like little bit tough, so I'll tell you the easy way. So put one rubber band like this, okay, and keep it over here, and you need to pull the rubber band from the other side. Pull it from other side and pull it. So this will be same in the other side. Put one rubber band inside the tool. Put it from the other end. It should come out. The stick is inside. You should keep the stick outside. Yeah, that's perfect. Thing is, like, if it is the range age group is from 3 years to 6 years, 2 years to 6 years, right? 6 years it can do it. Okay, if it is a 2 years kid, you can do the experiment and not show them. I mean, there is little more work out there. Like, I'll be coming to that. So you can do the model, and you can ask the kid to play with the model. Play means, like, you'll be I'll just come to that one later. So based on the age group, you can choose it. The last step is take 2 rubber bands and put it inside like the previous one. Okay. And then it should go behind it. So one top stitch and the middle stitch, okay? So it should go like this. Go behind it. One is enough. Side stitch, one is enough. Yeah. You need to take the card, whatever top you need, that you need to take out. So for that you need to take 2 rubber bands and put it in the stitch. And then keep it like this, and you will be tying the rubber band to the middle stitch. Like this. So this one will be tied. Yeah. So it's similar to the previous process. Then you need to put the rubber band and yeah, like yeah, perfect. The two should go together. So you will be able to do like this. If you want to do it like this. No, yours is you need to keep the stick behind. Yeah, like that. That's it. No, correct. It should be behind. No, only one hand. That's fine. So if you bend it like it will retain the put the figure, yeah. It will come back to the original position, right? If it happens, then it's proper. don't release it immediately. Just fix it and keep it aside. Like since the top is not fixed properly, it will take some time.
Only one seat you have to keep there. The space is 12. Here only one, not this side also. That's why it is 12.
Oh, yeah. Other end is not required. This
Other
end is not
side is
required.
not necessary.
Oh, I'll come back to that. So this thing you can start continuing like, I mean, procedures are, we need to cover another 40. So we take this much time for one thing like this, it will affect the other experiment. So still whatever you have completed, you can just stall it like that, and maybe in the break like you can start continuing. Okay. So this is the model like whatever you might have got it. So, and from this result it will be clear like you can keep some object like chalk paste or some rubber or something, and if you pull it and release it back, it will throw it away. Okay. So as ma'am asked, our 2-year-old kid can do it. See, for the 6-year-old kid, you can engage with this thing. Yes, right? So that's not a problem. For a 2-year-old kid, you can have the setup in your hand, okay, and you can give this to them and ask them to play. So they can keep some object and keep playing this with it. Keep playing. And you can ask the question like, you can ask that like, if the chalk piece is kept and if you pull the trigger and release it, it will be falling here. Okay. You can ask the kid like, can you do something to make it fall further? Okay. You need to keep asking question actually. There is no standard procedure or fixed questions or nothing like that. Yeah. Maybe like the same thing itself. Maybe I need suggestion from you. Like, how can you increase the force? Suppose say this is the force. Okay. Suppose say if the chalk is still there. How can you increase the force?
No.
Yeah. One thing is, if you add one more string like this,
Then it is.
that swing, lengthy swing will increase more force. Those principles are they don't require it, but they'll do some trial and error and get something. Okay. Is there any other method to increase the force? If the object is heavy, the distance force will be more. I mean the impact force will be more, but the distance won't cover much.
Yeah, it will be less.
Okay. So here in this mechanism, whatever we are doing it, we need to do with this mechanism. So is there any other way to increase the force?
The string, tighten the string.
Yeah, tighten the string. Or you can make some little bit or can you say, if you put one elastic like this, the bottom. Put one elastic like this and pull it and you use two elastic like that, it will increase the
Elasticity.
force will be more actually. It will go double the time. Even again, if you put one more elastic here, one more rubber band and tight with the other end, it will be at the maximum force. Even this will be the maximum force. Okay. Even if the 2-year-old kid is not able to answer this also, you can give some 2-3 sets, ask them to give some different objects and ask them to play with. Even this, if you think like this is tougher, you can keep different objects and ask them to play. So you can ask them like you can ask them to predict, okay, given us 3 objects, which one you think it will go further? Yeah, they will predict it actually. And then you ask them to test it. Okay, now you predicted right, just test it. So that's how you need to keep evolving on any experiment. Whatever experiment you do, there is no fixed set of questions or something. You need to keep asking as much as questions possible. Sorry? Right now it's not glued. Once it is glued, you'll be keeping the object like whatever. It's just for holding purpose. If you keep something here, it will keep rolling down. It's just a holding. You hold the object, then once you do the, so it will stay in the position.
Always giving me only.
Okay. So it's the same thing, like with the same principle. With this thing, like it would have got a logic actually. Yeah, some elasticity, something is done, some bands and all. If you connect it properly, it will pull some releasing power is there. Okay. If you see right now we have given 11-6. Suppose I give 7-6 or 3-6. Could you able to do some mechanism similar to this? So in that way, like you can ask it to think about it. This is for a 6-year-old, like the maximum age. Okay. So in that case, like you can ask them to do it. So they'll do some trial and errors and come up with something. Or some kids may come up with a rubber band like this and yeah, some 2 things if they put. Yeah, still I have the. So many ways are there to bring the same concept. So and one of the concepts could be like this actually. So this is similar with the, you can do it with the 4 or 5, I think. So 2, 3 you need to bundle it together and put some, you need to put rubber band on both the ends. And again one V-shaped stick you need to do and tie it in the middle. Then once you press and release like this, it's like you'll be using a clip for holding the top, right? It will be similar principle. So once you press and release it, again this will be after the kind. With the same experiment, you can ask the, this is not, that is, if this is if one experiment you are doing, it no need to be, science means, it no need to be talk about science alone or it's not like that. Same thing, if you could able to use it for math, yeah, you can use it. Suppose say, based on the projector, you can, using scale, you can ask the kids to measure the distance. If they are able to know the numbers more than 50 or 100, you can ask the kids to measure the distance using scale. So that sort of alterations you can do it on your own. So maybe like this will keep it aside actually. Or else like we can't cover the other topics. The next topic is on rockets. Like you can ask the kids like, do you know how the rocket works? Have you seen rockets? And sort of in general, you can ask like, have you seen the even like they would have not seen the rocket which is going in the sky. Like at least Diwali rockets they would have seen. Okay? You can ask them how it works. They'll say that no, there is some big cylinder kind of thing is there and stick is there, and once you fire it, there is some fire coming out of the bottom and you push it. So you can ask them like, which is the one which is the rocket off. So the fire is coming to sound and speed. Now that is the one which is pushing up. Okay. Can you do something with your? Can you do something with your on your own, like given this sort of component and sort of thing, like you can ask the kids to blow a balloon. You can give some balloon, and you can ask them to blow it and hold it, and just ask them to release it. Let them feel how the balloon reacts. It will keep rotating like without any control. There won't be any direction or something. Sometimes it will keep circle, or sometimes it will go straight, or sometimes it will be in any direction. You won't be having any direction. Okay, that is the regular. And there won't be any kid like who is not like familiar with balloon. This they might have seen this activity and all. They might have seen it, but they won't be realizing it. So if you start asking the question, they'll realize like what is that and all. Okay. So in case of balloon, you can before starting this balloon rocket experiment, you can just start with this some kind of interesting concept, and then tell him that okay, give them some balloon and ask them to play with that. Okay. So as I said, it will be going in a different direction. But rocket means you need to have a control. It needs to go in a particular direction. Is there any way to? So I want to go my balloon from this point to that point. Is there any way to guide the rocket? The principle is same. The original rocket also works in the same way, but the direction is based on the angle and other things. They do some higher end computation to do those balancing. Whereas what we are trying to do is in a simple way. But this is the base for that also. So what we can do is the same concept, like whatever the balloon is blue and leave it, it goes in a irregular direction. To guide the direction, to guide the balloon to go in a particular direction, what we can do is, you need to blow the balloon, and you can use a scarf, kind of not a very soft, little bit rigid it should be. Okay, so you can put a carbon tape on top of that. Okay, and you can use a thread. You need to put a thread inside the straw, and one end you can fold it or tie it in one end. Other end you can tie it with some other distance. And once you release the pressure, so now it is a guided activity. This balloon won't rotate. Okay, so it will be like a projectile. It will go in a straight line and leave in the destination. Got it? Yeah. I mean, yeah, that's what one more thing. There is, you don't need to worry about there is no standard procedure. Any experiment you do, there is no standard procedure. Even this could be used with the other number of students. But while teaching to kids, you can say the procedure. But as a teacher, like, there is no, you need to understand one thing, there is no fixed procedure. Okay? This is, they have tested the tape in 3 ends. So if it fixes, if the tape is fixing properly in one end itself, you don't require it. They have chosen a lengthy straw. Okay? What will be the problem if you use a lengthy straw? Putting the thread in one end and taking it out is a big deal. It will take lots of time. What we require is, we require something to guide it. So we can use the straw as small as possible. Got it? So for this, like, so what we'll do is, we'll take some 2-3 steps to test this experiment actually. So everyone start doing that. So we'll take some 2-3 tests and tie it from one end to another end. We'll see like how it works. Okay. So please start on this. You can cut and use it. and you can cut it so that like yeah. The thing is, you need to tie the thread in one end, any one corner. Okay, and another end will be in your hand. The thread should go inside the straw. Okay, so other end you can hold it tightly, and if you leave the balloon will move. Instead of going in its own direction, it will go in a straight line. The direction in which the thread is tied.
Yes, you can.
Anybody is having thread?
Yes, sir. Yes, you can.
Huh? Doesn't matter. Be a little bit strong enough.
Yes, some of, you can. Yes, you can. No, because don't fall. Don't like happen there.
Can cut this. Can leave. Excuse me.
Now we can.
So you are increasing the respiratory capacity?
Yes.
Very good. This is also way of taking where lungs ferment in the body.
Hold it like this. Right now, if you leave it like this, there is no control. Okay? Okay? This is till the end. And this is the, basic thing. In this also, there is no fixed definition or something like that. So here, you can, sorry? Okay.
You can take that. You can take that. It's very good.
Yeah, same. Yeah, we can take it.
Same way you can use it. Is that मेरी तरफ मुंह करो. Directly मेरी. Oh wow.
Or is it reverse?
That's what I am telling. So if you take the directives which way it has to go, otherwise it will put like this. Come, it is going to Mars. It is going to Mars. From PSTTI to Mars. Ready? So ready everybody? So there is competition between two people. Oh, someone knows. You have to, you have to 1, 2, 3, which one?
Yeah, count down. Reverse order में बोलना है. Hold it down. Yeah. Follow. 1, 2, 3. Cross. Experience. Yeah.
Makeup on you. Then still खाली आ जाता है. अरे हाँ यार मिठाई. So start.
Ready?
Ready? 1, 2, 1, 1, go. That's one advertisement, sir. You don't know the excitement. He's just putting excitement back to the body. You only release. Everybody can come and learn their balance.
The same stuff. Take the small toe. The thread के अंदर यही है. You have to use this.
So, clap for us.
Okay. See, you can, create a curiosity to the kids by showing this as a sample. Okay. But this is not the actual thing what you're trying to give to the kids. Okay. Okay. You're creating the curiosity. Post to that you need to ask question actually. By keeping two threads, the lengthiest distance, you can ask them to do it in the same way. But if it is the length is more, if the length is more than this length, okay, it will stop in the middle itself. You don't reach at the end. You can ask the kids to, you can ask the kids to do something to move further. Same balloon, the kids need to do something to move it further. Okay, what can be done? Anything could be done with the same balloon and the thread to move it further. Or else I'll put the question in other way. Okay. Two threads are there, and one is a bigger balloon and another thread smaller balloon. It will go further. Why it is going further?
More air
is there. And the air coming out of the to empty the balloon, it takes more time. Okay. So now two big balloons are there. Okay. Once you leave it, it reaches half of the distance. Okay. So the condition here is you need to do something with the one balloon needs to go further than the other balloon. So what you need to do is you need to limit the air going out. So what it can do is that?
Slightly you can tighten it and release.
Tighten that, or you can put one star there and tie it up. So without star, the whole, the gap is bigger, right? The air coming out will be more like, it will be faster. If you limit the air outflow with a star, you can tie a star there also, and it will answer you, or else like once you make them to play with this thing, with this question, they will do some sort of thing and come out with something. Okay? And also one more thing you would have noticed that if the thread is loose, you get stuck in the middle. The thread should be tight enough to go further. If the thread is tight, it will go further. Okay? It could be for any. Your questions, yeah, your questions will change. Yeah, that's what I'm saying. For the kids, like you yourself can demonstrate this thing by, and for a 6-year-old, you can expect the answer from the kid. Instead of telling the answer directly, you need to. I mean, I don't have enough time so that I'm not spending much time in getting the answer. If I ask you can by asking so many questions, you can get the answer from the kid itself. That's it. The thread is for directing that in which angle it needs to go. Okay, we'll go with the next one. Simple balance. You would have seen the weighing balance from all the shops, right? So the idea here would be, this could be like you can teach the kid how to make a weighing balance. That will be in one angle. Another angle, you can teach the kid how to measure the thing. Okay. So here, like for this experiment, we have chosen a hanger. Okay. That's a special type of hanger. It should have a weighted like this. Generally, you can tie something. If it is a plain hanger, you can't tie any weight over there. So anybody having hanger? No, right? Can we do some replacement and do this? Pencil. Okay. What we can do in the middle, you can just measure the middle approximately and put some thread and leave it for holding purpose. Okay. Other two ends, you can have some. In other 2 ends, you can have two more threads and tie it to the paper cup, whatever you want. Yeah. Don't use rubber. Use thread actually. Rubber band. Keep moving. Okay. So you can use scale or pencil for the printer. Also like the paper cup you can use it. Using pencil or pen you can just put holes in paper cup. No need to put, you can do it like this. The single thread is enough right now. I mean, while you are doing it, you can use 3 threads to make it look like a real balance. Metallic you won't get it easily. You can use pencil or anything. This is heavy, right? A little bit one side also. Yeah. So this is another similar kind of can be a replacement for an hanger. Like this is like well balanced. Like, you don't need to find the center. So like you can make use of the components, like whatever you are seeing, you need to be able to make use of it and build your experiment. That's how. Don't worry about the balance. Make the set.
Anybody else? No, yes, can you just share it? Want some more? Where's it?
Don't worry about the balance. Size and constant. That's fine. That's it. Yeah. Okay. So I think like now everyone knows how to make a weighing balance, right? Still someone might have, some of them were not completed, but it's fine actually. See, here in this experiment, the more I have approached it, I have given a image and then asked you to try. Okay? You might have seen that. Is there any two weighing balance which is similar? Everything like you have achieved the weighing balance, but each one is a different design. See, there it is a different design, and I think there is no two similar weighing balance like this. Okay? Okay. Once you complete it, what is the main issue you got it? So punching the curve, like you won't be having an issue. What is the main issue you are getting? Balancing.
Yeah.
This is the like making the kid to balance the weight balance itself is a big task actually. They'll understand like they'll think like why it is going down. Okay, so if I move like if I move a little bit like that, what is happening? So before you're not doing any weighing down, any weighing experiment. But to adjusting this itself like so that's the specialty like if you do something on your hand, the amount of weighing knowledge is more than you can use a ready-made weighing balance and ask the kid to weigh and do the experiment. But that's different. But here you are understanding the basics itself. So just balancing to making the hookups to balance each other itself, it will take a lot of time in that. In that itself, you'll be okay. Oh, this is something. The weight and all, like he'll take it. Yeah, why it is? He'll start thinking like why it is going down in one side and sort of. To make it adjust, we'll pull it like this. So then only like once you give a weight and an object to measure it, if something is goes down, you'll know which is heavy. To know which is heavy, if something goes down, it is heavy sort of things and all, you need to understand actually. That understanding will come once you use this sort of basic experiment. Okay? So once assuming that everyone is done with the weighing balance, okay, now we'll go with the some of the some more extra experiments on that. Okay. So task would be like object sorting using weighing balance. Okay. For this task, you can use a proper weighing balance, or you need to make this weighing balance itself as a proper one. Anyone you need to do it. If you are doing some weighing balance on your own, it should be a proper. There it should not be. You need to do adjustment and all. You need to put that knot, everything tight, so that it's no need to put effort in adjusting the weighing balance. Okay. If you could able to make it in that one, it's fine. Or else you can use a regular weighing balance, like toy weighing balance are available. You can use that for teaching this experiment. So here the task is you need to give some 5 to 10 objects to the kid. And it should not be in the same structure or something. It should be in a different structure and different. Something could be in a plastic, something could be in a iron, or something could be you can use a stone also for that. Some mixed objects you can give it to the kid, and you can ask the kid to sense it actually. You can ask the kid to sense and predict the weight actually, which is the heaviest of the 10 objects. So a kid will take each one and he'll do the analysis actually. So he'll take, he'll handle each and every object and he'll sense it which is heavier, and then he'll predict one object. So unknowingly he is using some algorithm to do this prediction. Okay, but if you see in an engineering process, like one who completes the engineering and coming out, he is given the same task: find the greatest among n numbers. So given input will be some 5 different numbers. You need to write a program or some logic to find the greatest among the 10 numbers. Okay, if the particular guy, like, and I guarantee like almost like only 5% could able to solve this problem. Okay, but if it's given him some kind of, that is like 5%, he need to write an algorithm for that, step by step. Okay, but given a 10 numbers, if you ask him to find which is greatest, he know how to find it. He has the algorithm, like it is registered in his memory, but he don't know how it works, but he can find the solution. But if you want to take out that algorithm, it's tough for them. So once he could able to take out that algorithm, that's the business for him, or that's the target for him. Okay, so here by doing like this, kid can able to figure it out. Suppose then 2 things are there. Initially you can give some heavy, maybe some 500 grams and 1 kg, so that it will be easy for them to get the feel around. Then you can reduce the, you can increase the similarity. It could be like 100 grams, 200 grams, 300 grams. Okay, so that they need to focus a little bit more. So gradually you can increase the similarity. So then like their sense would, you get more actually. The sense of playing it without a weighing balance will be more. So post to that, what you can do is you can ask the kid to the actual task is getting the sorting the weight in an order, or picking the heaviest weight or lightest weight. So if you ask the kid can build a logic. By trial and error, he'll predict, somehow predict. At least some 3 out of 10 kids will be giving a proper answer. Okay? But the problem here is to understand like how they are doing it. So they are doing it without any understanding. So for that you can ask them to, you can give the procedures actually. So this is the weighing balance. Out of 10 objects, take first 2 objects. Keep it in the weighing pan. Whichever goes, suppose the task is to get the heaviest. So whichever goes down, you leave it there. Whichever goes up, you take it out and keep it aside. Okay. Then left is 8. You take another 1 from the remaining 8 and put it in the balance. So whichever goes, out of those 2, whichever goes down, leave it. Whichever comes up, just take it and keep it aside. So this is the algorithm what the engineers, like actual engineers are doing it. This is the exact problem engineers are doing it. But the thing is, if you initiate this thing in the beginning itself, their skill set of analyzing and looking into the problem will be entirely different. Okay, that's what we are putting this task only. We are trying to educate as an engineering concept under the STEM. Okay, so this sort of like this you can do for this itself, weighing balance itself, sorting in an ascending order, sorting in a descending order, heaviest among all, lightest among all. Like this you can keep changing the problem. As I said, there is no fixed problem or nothing is there. So you can keep changing your task and start giving the task to the kids. Got it? So with the weighing balance, you are giving the sense of like how the balancing needs to be done for the kids. Then once you've done that sensing, kids will automatically identify this is heaviest. Or else if you given a weighing balance, You don't know, like once it goes down is heaviest or once it comes up, one which is property. But if you do the pre-tuning, they will automatically understand. The thing is, like, we should not educate the kid, we need to make the kid to educate on its own. That should be our objective. So the objective, once you follow the standard, so it will be easy for them, like whenever you give a new task, it will be, they themselves will start picking up the things easily. Or else everything will be a spoon feeding. If you tell them, like, this is step 1, step 2, do this, if you give a new task, they will expect the same step 1 and step 2 from your end. Got it? So object sorting, like, are you clear with this? Okay. So next the wing loop. Here, like, we are trying to educate the kids, okay, the intensity of wind. Okay, intensity of wind is, like, it could be very less. I mean, like in a fan, if you keep the fan in 1, 2 or 3, so the 3 speed modes are there. If you keep it in more, 1 it will be like less speed, 2 means it's more speed, and 3 means that's the maximum. Okay, so you need to what you are trying to do, you need to you're educating the kids to identify the speed in which the fan is running. So without knowing the switch and sort of things like that. So what you are trying to do here is it's a simple thing. Here also components about nothing. Here right now we are using the wooden yarn, white sheet, and telephone tape. Here in a sheet, like, you are just using two woolen strings and taping it up, like this. It's a straightforward, right? You are able to understand, right? So these things are done and sticking it up. So I'm just giving the input and just sticking it up. Okay? So, and the other end, you are using a lead string. So, two size things you are using. Audible? No?
Yeah. So one is a short length, another one is a lengthier one. Okay. Here, like, we know that actually, I mean, if you ask generally, like, which one will blow, if the wind intensity speed is less, which one will blow faster, means we'll easily say that the smaller one will go fast and the lengthier one will take. If the intensity is more, then it will start moving actually. Okay. So what you can ask the kid to do is, you can put a fan, okay, and keep it in 1, and you can ask the kid to choose the length of the thread. So ask them to try with a smaller one, lengthier one, whichever reacts for that particular speed. Okay, you can ask the kid to tie that particular, once the thread starts responding, you can ask the kid to paste it up. Okay, so for the speed one, your sensor is ready to sense whether it's a speed. If it is speed 1, this will start reflecting. Okay, and keep your fan in 2. Automatically the speed 1 will keep blowing it out. Okay, you need to put one more thing, lengthier one, okay, which will blow in the second speed alone. Okay, so when fan speed is 2, at that time alone that second string should glow. Second string should move actually. So in that way, like in the third speed also, you can put one more. Okay, so post to that, once the setup is ready, if you keep the fan over there and switch on the fan, only one string will be moving. And if you put it in the second speed, 1 and 2 will be moving. If you put it in the third speed, all the 3 will be moving. So this is like you are building a sensor itself. Okay, sensor means right now in windmills and all is there, right? Like where the big fan will be rotating and generating to the power supply. There they are using this similar sensor actually, but the concept is nothing. This is the concept, and the kid could able to build the concept actually. But without this is the one more thing that we are trying to. They'll understand the things easily. Whenever you give a problem, they'll look differently and give a solution to it. Okay, so this is the approach. Okay, is it clear with you? I'm not doing this as an experiment, I'm just keeping it off. Fine, right? So related to wind, and one more experiment is making a airplane, paper airplane, or something rocket kind of thing. Anyone know how to make a rocket or something? Everyone knows. Okay. Can you make one simple rocket and show me, like anyone? Rocket or aeroplane? Like.
We got one screen model for the video. So this is the structure. See, one is if you have a fan, like you can test it, or else like once you are moving it, you can see the sequence actually. So once you once you are doing the fan and doing a trial and error, increasing the length, right, you get a proper sensor for the data. So on seeing this page, the speed of data you have running in speed 1, running in speed 2, running in speed 3. There are so many other technologies. I'm so sorry, I said. So, as you see, like among it, like there are almost different types of airplanes are available. Okay, so once you try, okay. So here, so you got right. So different types of aeroplanes you are seeing, but the problem is so many problems you are facing. What is the problem? Like once you launch it, it's not going as per your direction. Okay, and if you say aeroplane, one thing comes to your mind is speed. Okay, so though you apply more force, it's just doing some round and coming back to something is doing. Okay, suppose say one simple document, like you are doing a paper packing, right? So here, this thing like it will have, I mean, it will be having a, if you try launching this thing, it will go further actually. If you apply more force, it will be going straight line and in the, I mean, it will travel a little bit lengthier actually. Yeah.
Like this.
Okay. So the scenario is here like the shape, the architecture if you see, it will be like thin and the base will keep going in the evenly. And there is no wind of the current. There is no wind, much wind like which it will get, repulsed from the wind at all like this. Plane, and as soon as you launch the rocket, it goes straight actually. And it will go further distance also. Okay? And one more thing, this is distance, you need to have control over the launch. If you put something like you need to control it. Yeah, you need to go slowly or you need to stay in air for a long time. So you like rocket because like it stays in air for a long time. Other things are like wheels based and other things. This will stay in air for a long time. So once you make the rocket which will stay for a long time, that will be another challenge. Okay? This is the one which will this is the step like using which you can make one rocket which will stay for a longer time in air. Okay? So step one, you can take any A4 size piece of paper like that. I mean, it's not A4 size, it should be a little bit rectangular in shape like that. Okay? Shall we start? So make a fold, this is the second step. Make a fold like this. And by keeping the both the corners together. So you get a line. And then you fold it like this. Sorry? Yeah. The length side. Length was the thing like if you need to fold it like this, so these are the third step, and fourth step, to make one more video like this. And at the proper corner. So you come like this. And then we need to fold it like this. So we need to fold it partially, not as a three. Partially, and this corner should touch this folded line. Till this you have done, right? Okay. You need to pick one corner and fold it like this. And you need to fold it till the corner touches the flat.
Both the sides?
Yeah, both.
Both the sides.
Once both the sides are done, and this middle part of the triangle, you need to fold it back, and it will get closer. So all the folding should be symmetric, like if one corner is going out and all, like it will lose the balance, it don't go in a proper way. So everything should be in a symmetric. Symmetric means that both things should go, I mean, here if you see both the things should be joining at the same location. So it will get like this. And then you need to bend it. Because the corner. will be a little bit smoother compared to your previous design. That's not our design again. So people do like that. Yeah, that's the problem. See, this is what you will be getting it. Otherwise, if you do it, you will go in a different thing. This will be the technique. You don't need to push it also. If you leave it in a particular height, it will move, start moving. And with the same thing, if you want to increase the speed, you can bend it with one more code you can do it, and you need to adjust it properly like this. So it will give a little more like distance curve. That's how we do it. One more is behind you.
Behind you, one more is
So once it's properly done, okay, this folding part, this is sub-folding and then like you can ask the kids to try it. You can, this wing size, this folding size you can keep varying it and try it. Okay, we'll go with the next one. So this you got it right. One is like you can ask the kids to try their own. Okay, it will be coming different direction. You can explain the demerits of the what are the flight like whatever they have made. With that like you can just by throwing it out you can say that oh it's not going as per my direction. Somewhere it's rotating and sort of things and all you can tell them. And you can based on your new design you can say that like how those things are getting recovered. Okay. So we'll go with the next one. Side match. So yeah, like these things are like pretty simple. While teaching maths to kids, like you need to use as much creativity and you need to attract them a lot. Okay. So if you want to teach something to the kids, you need to make them to listen. Okay, that is the first hectic job, hectic possibility. So if they are not listening, like whatever novelty way you are using to teach them and all, like everything will go away. So for that, like you can use James and all, like they'll be already familiar with like what is James and all. You can use that, or you can use candies for doing math, or you can use dolls for doing math and sort of things. That you can do that. So one approach is file math. Okay, this is like pretty simple. Suppose they are assuming that the kid knows from 1 to 100. Okay, the numbers are, they know from 1 to 100. For that, like you need to teach some kind of like counting. So 1 to 10 they can do the counting properly. So post to that, they want to count it from till 100 means it will be little bit tough. So to teach that part, that we are using this methodology. One is like, you can ask the first part to be like, you can ask the kid to group the gems in a 10-10 count. Okay? 10 in a group, you can ask them to group it. Or 5 in a group, you can ask them to group it. And you can do a cumulative counting post to that. Okay? Based on the age group, you can do it, you can vary the number actually. For example, if the kid knows only from 1 to 10, you can start them to, you can ask them to group it 2 to gems. Okay? And cumulatively you can ask them to count it. So here, by doing the group-wise counting, you are doing the addition. In the everything you are learning indirectly, but you are not teaching them how to do addition and all that. Everything they are doing indirectly. Okay?
Okay, everything they are doing indirectly. Okay, while using the gems individually and making the grouping. Suppose it might be two in a group or 10 in a group. They are just counting one by one. There comes the addition. If you say the threshold as okay 2 in a group means they will be conscious in making it 2 in a group. So 2 candidates they'll put it in a group and sort of thing it will keep going. So their addition. Post to that, once you say that once you got some 10 in a group and 10 such groups are there, while doing a total counting it will be 100. For that you can teach them like you can ask them to go with like one group once 10, then 11, 12, 13 in the other group, sort of thing you can go. That comes again lengthier addition, or else you can ask them to use group wise, first group and second group you can ask them to count, and both together if 2 10 groups are there then it is 20. Then indirectly the multiplication comes into picture actually. So you can you got it now? So multiplication, like if you are counting individually, then the addition comes. Like once you count it as a group, so first group is 10 and second group, first group is 10 and second group is 10. If you are counting one by one, then the addition. If you can ask the kid to count both the groups. He'll count and say and it is 20, and you can explain them like 10 and another 10 is nothing but 20. So similar to that, this is not a one-time activity. It will be like it's a prolonging activity. You need to keep on doing it till the child learns to get this knowledge actually. So this activity, once the child knows how to group it, it's nothing but 10th table. So 10th table, like whatever they are learning it in the 6th or some kind of higher standard, that they will be getting the basics of what is that multiplication. So when they are given the tables, like when they are given the activity to learn the tables, they will be looking the tables in the actual thing instead of just mug-upping. They will be looking the actual logic, how the multiplication is happening, and they will start proceeding the learning. That's the objective. Here you are not trying to teach maths also. You are trying to teach some different way of looking into the addition and multiplication. That's it. At the end, don't worry that kids is not doing properly or something like that. It's not. We don't need to worry about it. So we need to, this way of activity, you need to keep growing it. If the kid learns, follow that. Okay. And one more thing is, with the same thing itself, by writing the number like 1, 2, 3 on board, okay, you can ask the kids to arrange the gems in that particular number shape. So here by drawing 4, you can ask the kids to arrange the gems in the shape of 4. So this will register in that mind very well actually. Instead of just writing 4, 4, 4 on the continuously on the board or on the paper to make them register, this will take long. I mean, the thing is, to arrange in the shape, the kid is taking more time, okay, which makes the kid to concentrate on that particular number 4 alone for a longer time. That's what happening when you're writing 4 again and again. So normally to memorize something and all, like you'll ask the kids to writing 4 and you'll ask the kids to write 4, 4 and that. It's nothing but you're making the kid to concentrate on it. So nowadays if you're doing this with the small kids, they'll get bored and they'll go out. If the kid is a little bit older, you can force the kids to do it. Okay. Whereas doing such activity, yeah, at least one number or two number if it does, that's fine. So it's equivalent to this sort of activity, writing the code for 100 times or something like that. Okay. So next is candy corn counting and math. Okay. See, here we are building a platform for the kids to do the addition actually. For example, if you are giving five candies, and if you want the kid to count, the count of the candy is 5, you can, this experiment will do the job actually. Okay. The objective, the flow will be like this. You can have a chart and draw a tree kind of structure. Tree or anything, it could be a bus or it could be a car, like which will easily register. It should not be a complex object. It should be simple as this actually. So drawing this tree kind of structure is pretty simple. So you need to draw one such sort of object and you can number it. Okay. In the middle you can put a round and put different color. You can use it for numbering. If you are putting 8, you can assign the task to kid to fill 8 candies in the tree. Okay. Suppose the number is 5, you can ask the kid to fill 5 candies in the tree. So similarly, in a chart, you can have a different numbers, and you can ask the kids to fill into it. Okay. So that is one option. And while making this board, you can draw the structure. Okay. And you can draw this rounds also, paint it differently, and you can laminate this sheet without the numbers. Once you laminate it, you can use a whiteboard marker to keep changing the numbers actually. Okay. So the same sheet could be used to train for the other numbers as well. Got it? Not getting? Okay. See, what you can, while designing this thing, you can take a white sheet, okay, and draw the structure, like tree kind of structure, okay, and draw the number, make a rounds in the structure, okay, and laminate the sheet. Once you, but there won't be any numbers here. There won't be any numbers. So once you do a lamination, whatever you are writing on that laminated sheet, right, it's easily erasable like this whiteboard. You can use a soft whiteboard marker like this, and you can start writing it. Suppose if you write 8, you'll be changing the value over here alone. You'll be changing 8. And the next time if you want to change the same tree, you need to fill the 5 candies, you can just erase it and write it 5. So the same chart could be used for different numbers. Okay, similarly, some 2-3 structures you can put it, and we can make use of it. Okay. So can we do a model like this now? So each one, you can choose your own structure. Similar to tree, you can choose your own structure. It should be simple enough, and it should not be so neat. On seeing this stuff, yeah, you should get some idea. Yeah, this is tree or something like that. Okay, and you need to have a provision to make a circle, and you need to color the circle different color and the tree different color. Okay, and each circle, some different colors you can mention it. Okay, so take a sheet, choose your own object, draw the structure, put a circle, and for all the structure it should be same color. For the circle it should be different color. Don't write numbers in the sheet at all. So post to that, you can laminate the sheet and start using this with this experiment. Yeah. You will be giving the sheet and the candies to the kids. They'll start playing with that actually. On a, is it tea time? Okay, then you can got the concept, right? Does it? Sorry? You can use the corn also. That will be there actually.
No, it's wait, you draw and
No, this will be a, see, no. You can use it for, you can use it for the kids to concentrate on that. What you can do is, you can ask the kid not to eat anything. Once they do it properly, they can eat all the things. Yeah. Start eating it, yeah.
Addition won't be period of time.
No, this is also not required. This is like to register the shape in a kid's mind actually. So the activities could be, you can draw shapes in a different sheet. Okay. This sheet also, if you want to use it repeatedly, you can laminate the sheet. So once you laminate the sheet, that particular sheet, whatever you are using, you can use it again and again. Okay. And also use different colors for representing the shapes. Instead of same color, use different color to represent the shapes. And once the shape is ready, the games could be like that. If the shape is bigger, you can say triangle, and you can ask the kids to stand on the triangle. You can say that it will be like a game. If 10, 20 students are there, you can make them to stand in the round, and like each kid will be having the shapes in front of them. If some kid is missing, like it will be like that kid will lose some points or something like that. You don't need to put some points and all. Like if you say as a you lose or something, you are wrong and something, the kid will do the corrective measures. Why? Because the kids intellectual is compared among the others actually. Though it is not complex, if all the kids are doing properly, if one kid is not doing properly, that will give more impact on him, and he will correct it immediately, and it will register in his mind for a longer time. Okay. So this sort of games you can do it. Also, if it is in a sitting environment, on the desk you can keep this thing, and as soon as you say this, you say the shape, you can ask the kid to keep the hand on the particular shape. It could be a mixture of shape. Initially, you can start with one shape at a time, or then triangle and circle, triangle and rectangle, sort of thing. You can mix and start asking the questions. If you mix and start asking the question, the precision get increased actually. They need to, instead of thinking one shape at the time, they'll be thinking two shapes at the time in the mind. So once this two shape is completely registered, then the single shape will be permanent actually. Okay? So you need a break or what? Or shall I continue? Yes. Okay, we'll take a break for some time. You want lunch break? I think it's tea break. Are you want to do it now or you can take one more time?
If you're tired,
No, I'm not tired. Break will be there, no?
we give them a lunch break only directly. 12:45, 1:15. Half an hour. 12:30, half an hour. 1 hour.
Okay. We'll take lunch break for another half an hour. Okay.